Recording in progress.
Hi students, in this lecture I am going to discuss problems based on collisions. Let us see. So if any question given from collisions, we have to use it is a coefficient of restitution. So first we have to write momentum equation. So law of conservation of momentum. Next taking coefficient of restitution. And next one, if any condition is given. Suppose a collision is elastic. If a collision is elastic, we can write kinetic energy before collision is equal to kinetic energy after collision. Next, if any other condition they have mentioned, we have to use those conditions. So any question from collisions, focus momentum equation, coefficient of restitution. If collision is elastic, kinetic energy just before collision equal to kinetic energy after collision. Next, any conditions they have mentioned. Okay. Let us take one simple question. Suppose question is given like it is given like, let us say two bodies. Suppose mass is 1 kg, m1 is 1 kg, and m2 take it as 2 kg. Its velocity take it as 3 meter per second, and both velocities along same line. Okay, and this is take it as 4 meter per second. So both velocities along same line, and that line is called common normal direction. Okay, because of four sets along same line. Four sets along same line. Right. So now we have to calculate their velocities after collision. Means V1 and V2. Okay. So first we have tried conservation of momentum because on the system no external force is acting. Next, force by this one on second body or by this one on the first body becomes internal force. Okay. And because of these forces, their momenta change. Their momenta change. Okay, but coming to total momentum per system does not change. So first I am taking here. Let us take right as a positive. Then coming to momentum equation, writing law of conservation of momentum, m1 v1, that is 1 into 4 direction right side, so positive. Next second one, m2 into its velocity u2, that is equal to, after collision their velocities may be in the same direction or they may change. When we are not knowing, we simply assume that they are moving the same direction, means their values are positive. So it is now 1 into v1 plus 2 into v2. You can see here number of unknowns, v1, v2, two unknowns. So we require one more equation. Okay. So here nothing is mentioned regarding coefficient of restitution. Let us take E value 3 by 4. Then see what we can write. Coefficient of restitution is equal to V2n minus V1n upon U1n minus U2n. See, the upper one is giving velocity of separation. Okay. See carefully V2n, velocity of the second body after collision along a common normal direction. This n stands for common normal. In the same way, V1n, velocity of the first body after collision along common normal. This is giving us velocity of separation. Okay. And here, actually, we have to take U2n minus U1n. Okay. But we are focusing only modulus value. I will write here once again. Actually, we have to consider E equal to V2n minus V1n modulus of that upon U2n minus U1n, because one is velocity of separation, other is velocity of approach. If one is a positive, other becomes negative. So we have taken the modulus values. But here I have taken directly reversing that U1n minus U2n. Means if this is a positive, this is also positive. Okay. That's why I have taken directly, instead of taking modulus values, reversing U1n minus U2n. Okay. Right. So upper one is velocity of separation. Lower one is, means denominator is velocity of approach. This is equal. In case of one dimensional collision, this V1, V2 are nothing but, we can see, after collision, their velocities will be again along same line, maybe right or maybe left. Therefore, directly we can write V2 minus V1 upon U1 minus U2. Okay. So this we have to focus mainly when we solve oblique collisions. Okay. That means here U1, U2 are nothing but U1n, U2n, right? In the same way, V2, V1 are nothing but V2n and V1n, right? Next. So here after collision, their velocity directions we are not knowing. So we are assuming simply positive. Therefore, here V2n, that is V2 minus V1 upon U1. U1 is 4 minus V2. V2 value 3. So equation 1 and equation 2. So we have two equations and two unknowns. So by solving, we can get V1 and V2. So like this, we can solve problems basing on collisions. Okay. Let us see one problem. See the question carefully. A body of mass 1 kg makes a head-on elastic collision with another body at rest and continues to move in the horizontal direction after the collision with a velocity equal to 1/5 of its original velocity. Find mass of the second body, right? So first write down the given data. Given mass 1 kg, head-on elastic collision. Elastic means E value is 1. Second body is at rest. Continues to move in the original direction after the collision with a velocity equal to 1/5 of original velocity. Okay. See how we write equations. So first write down the given data. Given a body of mass 1 kg, its velocity take it as u. Okay. It is making a head-on elastic collision. Elastic collision means this velocity must be along the line joining their centers. Okay. This velocity must be along the line joining their centers. Then collision becomes head-on. Given elastic. So E value is 1. its mass we have to calculate. And for this one, after collision, velocity becomes, that means V1. V1 equal to 1/5 of original value and direction given same. So this is now given data. So first one, writing LCM, law of conservation of momentum. Then see what we get. 1 into U, that is momentum for first body. Second body is 0, so plus 0, that is equal to, after collision for first body, 1 into U by 5, right? For second one, we are not knowing that. Let us take M into velocity equation 1, right? Next, given E value 1. So E value 1 means it is V2N minus V1N upon U1N minus U2N. So V2N is nothing but V minus V1N is nothing but U by 5. So U by 5, that is equal to, U1N, that is equal to U, right? It is U. Remaining minus 0 because second body was at rest before collision. So now having two equations and two unknowns. One unknown is M, second unknown is V, right? Now see what we can write. From this second equation, we can get V value U plus U by 5, 6U by 5, right? Now substitute this in equation 1. In equation 1, if you substitute, see what you will get. U minus U by 5, 4U by 5, 4U by 5, that is equal to M into V value 6U by 5. Okay, U by 5, U by 5 gets cancelled. Remaining is now M equal to 4 by 6. That is 2 by 3 kg. Okay, so mainly understand how we are taking LCM, means law of conservation of momentum, and next coefficient of restitution. Two unknowns, two equations. Remaining just calculation part. Okay, let us see next problem. See the question carefully. A body having kinetic energy 10 joule makes an elastic head-on collision. Condition elastic, E value 1. Head-on collision. All velocities will be along same line before and after collision with an identical stationary body. Given identical means same mass. Stationary body. Find the minimum kinetic energy of the system. Okay. Let us focus how to start the problem. We have to find the minimum kinetic energy of the system. So first of all, we have to focus. Collision is given head-on and elastic, right? Suppose mass is its velocity, take it as u1. Second body at rest, so velocity u2, which is equal to 0. Mass is m, given identical. This velocity must be along the line joining their centers. Then it becomes head-on, right? Okay. Now, if you observe carefully, since a collision is elastic, just before collision, just after collision, kinetic energy is the same. Okay. But during the collision, what happens is shape of the bodies will change. their shapes will change. That means some part of the kinetic energy converts into deformation potential energy. Okay. Now he is asking minimum kinetic energy. Kinetic energy minimum means that potential energy is the maximum. Okay. So when potential energy is maximum, their velocities will be the same. Students, if you remember, in center of mass, we have solved a question like two blocks are connected by a spring which is massless like 3 kg, 6 kg. They are given some velocities like this. Find the maximum compression. Compression maximum means spring potential energy maximum. That means for the system, kinetic energy is minimum. So in that we have discussed that at the time of maximum compression or at the time of maximum elongation, their velocities are equal and equal to velocity of center of mass VCM. Now exactly same logic here also. When kinetic energy is minimum, their velocities will be equal to velocity of center of mass. Then see here what I can write. Velocity of center of mass VCM equal to, if u1 equal to u, it is equal to u by 2 because identical masses. This is zero velocity, this is u. So m into u by m plus m, right? Now take conservation of mechanical energy. Okay. Initially kinetic energy half m u square. At the time of maximum deformation, half for both bodies same velocity. I am taking directly mass 2m into u by 2 whole square. Half 2m into v square because for both bodies same velocity plus maximum potential energy. I'm taking it as u maximum. Then see how much we get. 2 gets cancelled. This is 1 by 4 m u square. This is 1 by 2. Remaining is now. I can write. It is 1 by 4 m u square equal to u maximum. Right? Or this I can write it as half of the kinetic energy of the colliding body. Right? Half of the kinetic energy of the colliding body. That means maximum potential energy is now half of the kinetic energy of colliding body. Therefore, minimum kinetic energy is equal to half of its initial value. Given K value 10, right? And a half means it becomes a 5 joule. That is the answer, right? So just comparing with this problem which we have learned in center of mass, right? While discussing center of mass frame. Okay, right. Let us see next problem. A body of mass m is dropped from a height h. Find the distance traveled by it before coming to rest. Second one, time taken by it to come to rest. Assume that the coefficient of restitution is e. That means between the body and the ground, it is e. Right. Let us see how we start the problem. Asking like distance traveled by it before coming to rest. So here what we can do is drop from a height h. mass is m. This height is given as h. Okay. So here what happens is, since collision is not elastic, energy will be lost. That means this body cannot rise to same height after collision. Okay. That means as time passes, its energy keep on loses, finally comes to rest. Suppose after first collision, it rises to a height of h1. Okay. After first collision, let us take it rises to a height of h2 after second collision. Let us take h3. It rises to a height of h3 after third collision. Then distance covered before coming to rest. It is distance traveled, that is equal to h plus see traveling up h1, again back h1 to h1, next h2 up, again h2 down. So plus 2h2 plus 2h3 and so on. That is now distance traveled. See once again, from here to reaching ground h. Next rises to h1, again come back by h1. Next rises to h2, again comes back to h2. So 2h1, 2h2, and so on. Okay. Right. Next, see what we can write here. See, coming to here, just before collision, velocity, take it as just before first collision velocity, take it as v naught. Just after first collision velocity, take it as v1. Okay. Then see relation between these two. Coefficient of restitution equal to v2n minus v1n upon u1n minus u2n. Let us take Earth as a second body, and this is now first body. That means for second body, velocity is 0 before and after collision. Means v2n 0, u2n 0, right? Let us take up as positive. Then v naught will be 0 because just before first collision, direction of velocity downwards. According to our sign convention, up is positive, then down is negative. Okay, up is positive. So v2n 0 minus v1n after collision, direction of velocity, it is upwards. Therefore, it is now upwards means it is v1 positive upon u1n before collision velocity downwards negative. So minus v naught. Minus gets cancelled. From this, what I can write? V1 is equal to E times of V naught. Okay. And next we get same condition. V2 by V1. I'm writing here. Next we are going to get E equal to V2 by V1. Right. That means V1 or V2 is E times of V1. That means what I can write? V2 is equal to E square into V naught. Because from this, V2 is equal to E times of V1, right? In the same way, V3 will be E times of V2. So I can write here V3 equal to E cube into V naught. That means after nth collision, its velocity becomes e power n into V naught. Okay, right. And we know velocity equal root of 2gh. So writing here root of 2gh height after nth collision, that is equal to e power n into v naught. That is now root of 2gh. Okay. See from this what we get. hn is equal to e power 2n into h. Okay. Now use that relation here. H plus. I'm taking 2 outside. In the place of h1, e square h. In the place of h2, okay, it is e power 4h plus and so on. Okay, let us take here e square h also outside, e square h. Remaining is now 1 plus e square plus e power 4 plus and so on. Okay, and you are knowing that this is expansion for you can see 1 plus x whole power 1, that is equal to 1 plus x square and so on, right? Condition is x is less than 1. Now in the place of x it is e square, right? 1 plus x square and so on. Okay, sorry, it's not power 1, it is minus 1. Okay, 1 plus x whole power minus 1. Expansion is 1 plus x square and so on. So here what I can do is, let us take h common, 1 plus 2e square upon 1 plus e square, right? See once what we have taken here. This is expansion of, anything wrong in this one? Just check it once. 1 plus e square plus e power 4. Wait, this is actually, it is 1 minus x, right? This is 1 minus x. 1 minus x whole power minus 1. It becomes 1 plus x square and so on. This becomes 1 minus, it is 1 minus, right? Now see what we are going to get. H into 1 plus e square, 1 plus e square minus 2 e square by 1 minus e square. Wait, this is a plus and this is minus, okay? So this becomes now h into 1 plus e square by 1 minus e square. Okay, this is the distance traveled before coming to rest, right? And see next what we have to calculate. He's asking find time taken by to come to rest. Let's see that also, time taken. Right. So we got result that it is Vn equal to Vn equal to Vn equal to, or wait here. We got condition that V1 is equal to E square into V naught. V2 equal to E power 4 into V naught, right? Generalizing that Vn equal to E power 2n into V naught. So writing the same thing here, E power 2n into V naught. Now writing this in terms of time. See what we can do in terms of time. Velocity equal to, when we are dropping a body from a height h, suppose the time taken is now t. Time taken how much? It is a t. Let us say after first collision, it takes a time t1 to reach maximum height. Okay. Again to come back, it will take time t1. Next t2, again t2, right? So here what I can do is Vn equal to e power 2n into V naught. In the place of Vn, I can write velocity equal to Gt, right? Velocity equal to Gt because it is now freely falling body. Okay. Velocity equal to Gt, or leave this one. Let us take directly what I'm writing here, E equal to V2n minus V1n upon U1n minus U2n. Earth is now second body. Our second body, no velocity, right? Minus in the place of V1, velocity after collision. That is now GT1. Okay, it is GT1. Okay, we are taking up as a positive. After collision velocity is upwards minus U1. It is down, so minus GT. Okay, or take it as a T naught. Okay, correspond to the first one. This is T naught. So relation between T1 and T naught. T1 is E into T naught. In the same way, we can write T2 equal to E into T1, which is equal to E square into T naught. Like this, Tn is equal to E power n into T naught. Okay. Now take that result here. Time taken equal to T naught plus 2T1 plus 2T2 and so on. Right now, what we can do is T naught plus take 2 outside in the place of T1. It is E T naught in the place of T2 is E square T naught plus and so on. Take a T naught outside. Remaining is 1 plus 2, 1 plus, see what I have taken here. 1 plus, take E also outside, 2E. Remaining is now 1 plus E plus E square plus and so on. Okay. And this is now expansion for 1 minus x whole power minus 1. 1 plus x square and so on. So we have in the place of x, it is now E. So this becomes now that becomes now, see what we get. So T equal to T naught into 1 plus 2E upon 1 minus C, right? Because expansion for 1 minus x whole power minus 1. Now this becomes T naught into 1 plus E by 1 minus C. Okay. Where T naught equal to root of 2h by g, right? For freely falling body. So like this, we can solve the problem, right?